Hello everyone. This is Jason from Supermap. I'm glad to be here to share the GIS technology and give the course of mapping and spatial analysis about using Supermap in the future, in the nearly future these days. First, please let me share my screen. All right, I think now all of you already can see the screen. Before the training starts, I want to introduce you the basic information of our training these days. So first, our training will be held on today, which is July 26th and 29th, and August 2nd and 5th, 2nd and 5th of August. And this document showing us some basic information of the training. First, this is the download link of Supermap softwares. You can we will use the Zoom platform as today and in the future. It will be all the same. And for the data resource, you don't need to download the spatial data for now. In the further training, I will lead you to download the needed data from these links. And for the Q&A platform, we choose to use Skype. And this is the this is the link of our Skype group. During the training session, if you have any question or any problem, please feel free to share your question to the group and we will answer it. For the submission, these days we will have some homework. These days we will have the homework for every day. And for your homework, we will use the Classroom, Google Classroom as the platform for you to submit your results, to upload your submission. And after we got all of the submission, we will issue the certificates for all of the participants. Okay, so this is the basic information of our training. And the second one is the event details of the comprehensive spatial analysis, both in 2D and 3D, enabling them to address future demands and global challenges more effectively. And the training syllabus or the schedule of the training is as below. We will have the training on 26th of July, 26th of July, 29th of July, 2nd August, and 5th August. This time is in the Indian Standard Time. You can, based on your country's different time differences, to calculate the time in your country. And the topic for today is the opening ceremony, what is GIS and its application, and then I will introduce you the latest progress of GIS technology. And the topic of second training, which is on 29th July, this topic is the spatial data processing and 2D mapping. After this day's training, you will have the knowledge on how to create a map using Supermap at desktop, and the homework will be creating a map. The third training topic is the spatial analysis. We have the spatial analysis for vector data and spatial analysis for raster data. And the last one, the network analysis and statistical analysis, 3D scene making and 3D spatial analysis, and also the closing ceremony will be the topic for the last day's training. And after the training, after the completion of hands-on session, you will be given a chance to take part in the Supermap GIS contest. This is a global GIS contest. The local GIS computation organized by the Faculty of Geomatics in conjunction with the SASUSL. And the International GIS Contest will be organized by Supermap. The award will be the winner or outstanding performer of the local competition will be awarded a marriage certificate with Chinese style gifts. Yeah, you will have a little gift as a Chinese style. And the winner of Supermap International Contest will be awarded case price of US $500. And also you will get a return air ticket to fly to Beijing, China, to go to the onset, have a last introduction of your results. And the rules is for all potential sessions and for the competition, the Supermap platform should be used. And the result can be submitted as a group or as only one person. And the important dates, the 15th August 2021 will be the submission of results to Supermap International GIS competition. And the 5th September, it will be the submission of the result to local GIS competition. The 3rd December is the awarding ceremony, local competition. And if you got the return ticket to fly to Beijing, you will go to fly Beijing around this stage. Okay, now that's all of the basic information and the detailed information of our training course today. And now let's go to start our topic. The first topic of today's training will be what is GIS and its functions and applications. So before we talk about what is GIS, I will show you what is geoinformation. The geoinformation is the information that are related with geographical position. And there are three composition of three parts of geoinformation technologies. They are GIS, GNSS, and RS. All of these three technology provide the capability to the geoinformation technology to help us to establish the applications such as smart city. So first is the remote sensing. The remote sensing means we can get the image data or satellite data by the satellite. And this is a very important data source for the geoinformation technology. And the next one is the GNSS. Currently, there are 4 GNSS systems over the world. In the America, we have the GPS, they have the GPS, and in Europe, they have the Galileo, and in Russia, there is GeoNet, and in China, there is a Beidou. So all of these 4 GNSS platform, GNSS system can provide the spatial position information to the users on the Earth. And the last one is the GNSS. The last one is the GIS. The GIS is from the real world. We can have the we can get the satellite. We can get the vectorized data and the image data together, and they can integrate with the attributes table to make the GIS platform. And based on the GIS system, we can achieve the function of such as query and analysis. And also we can make them as a map or output them as a layout to create the maps. And the relationship between these three technology is the GNSS can provide the digital position to the GIS application, to the GIS, and RS can provide the image data to GIS. And GIS can integrate this spatial data with business data to establish the application system. So the application system is like the software, the system we use every day, such as Google Map, such as the GIS system used by different government agency. For all of these kind, they are all for all of this kind system, they are all based on the GIS. So what is the GIS? The concept of GIS can be divided into three, which is G and I and S. The G is, we can understand it like it is the geographical expression. And the I is the information decision. The S is, it means system. So for the G, it is a geographical expression. Many of the issues in our world have a critical spatial component, such as the census data, the pursuit of land resources, the transportation network. So they are all geographical expression. And there are different methods of geographical expression, such as for now what you can say, it is a 2D map. And this 2D map have a lot of layers. The first one is image layer, and then the vector layer to show the administrative area, and also the road network layer, the point layer, and the label layer. So all of these layers combine together to make a 2D map. And for the 3D one, like this is a 3D scene. So based on this 3D scene, actually there are the terrain layer and also the satellite image layer and the road network and the label inside. This we can call it as a vector layer. So for express a 3D scene, we need this kind of layers or this kind of method to show it. And for I means the information decision. So talking about GIS, a lot of people will think about information, such as there are some decision examples. Where is the nearest gas station? Where is road? Which road is better for the relief suppliers transportation? And which place is suitable for a new supermarket? This kind of information can be provided by GIS. And so the definition of GIS is beyond a map. GIS is a technology that uses map to present, manage statistics, and analyze users' information. The last one, of course, is system. GIS, the method of those information provided to user is the system. There are a lot of GIS platforms such as ArcGIS, SuperMapGIS, MapInfo, open source. And talking about the type of system, first we have the CSGIS, which is client server GIS. This is a traditional architecture for the whole system. And currently there are more and more BS system, which is browser server system. And also the GIS can be run on mobile. So this is the system. Okay, and now we go to the second one, the basic concept of GIS. The GIS components can be divided into three parts. The input, in the middle one, it is the management, analysis tools, and the output. For the input, that's about the data. The GIS data always can be divided into two, which is vector data and the raster data. We use the vector data to represent geographic information via coordinates, and we use the grid cells to express the raster data. And for vector data, it has a lot of types like point, line, polygon. And for raster data, it is there are all the small grid cell, and the raster data is composed by grids or pixels. The grid or pixels value may be elevation, color, or other attributes. If it is a color, then we can say the raster data is a image data, like the satellite image or the image data from UAV or drone. And if the value of cells means some other meaning, such as the elevation or such as the pressure, then when it means the elevation, then we can call it as a single value based on the majority attribute in the cell. So such as it also can be the land use type, brightness, extra. So what can GIS help us to do, or what is the GIS functions? Here I listed some of them, such as the spatial data management, 2D display, 3D scene, query, data processing, data editing, spatial analysis, and output. So first, where can we get the GIS data? There are a lot of methods to get the data, such as by the manual survey, or from the RS, or from the satellite navigation, or even we can scan over paper map and to digital the data. And also it can be come from the 3D model software, such as 3D Maps. And now we have the BEAM, such as the Revit data. The Revit software can provide us the BEAM module. And for the data storage and management, first for spatial data, the GIS application need to handle the geometry and attributes together. And also this should be stored. This should be stored into the spatial database, such as Oracle SQL Server, IBM, and PostgreSQL or Oracle Spatial. For this kind of data, for this kind of database, some of them already can support the spatial data, but some of them is only the traditional relationship database. So the GIS software also need to provide the capability to let the traditional relationship database to support the spatial data, such as Oracle or SQL Server. And next function of GIS is data editing. It can provide us the capability of spatial and attribute data editing, and also the project transforming, the topology, the dissolve, the resample, smooth. They are all the data processing function inside of GIS application. And the visualization is always important. So for the 2D display, such as the layer style setting to show a 2D map, and for showing the 2D map, we use it can provide us the thematic mapping, like in different thematic layers, like unique value map, ranges map, and others. And also, yeah, they are all different thematic map. And in 3D display, we need to it can provide us the capability to load the 3D terrain and image, load the vector data, load the 2D map on the 3D scene and also load the KML data, the module data, and like the pipeline module. So the visualization of GIS is very important. It has different functions to support it. And the last one is the spatial analysis. After data is collected, we can do some spatial analysis with those data to solve the problems, such as the hydrology analysis. Based on the DEM data, we can get the river line from the river line on it, and the slope and aspect data, and like buffer analysis. This is based on the vector, and network analysis, which is based on the road network. We can get the shortest path from the point A to point B. And the 3D visibility analysis. In 3D, the GIS also need to provide the function of 3D analysis. And yeah, there are some detailed information like buffer, like grid analysis, and of course the output is one of the most is also the important function of GIS. Like we can make a layout and output it to suggest the PDF or print it directly. Okay, so this is the first topic about GIS basic concept. And now I will bring you the latest progress of GIS technology with SuperMap. So before that, I want to show you, I want to give you a brief introduction of SuperMap as a company. First, SuperMap was founded in 1997. Until now, there is already more than 20 years old. And we have more than 4,000 employees all over the world. And there are more than 1,000 partners in more than 30 countries. And over the world, we have 38 branch offices and subsidiaries. And SuperMap is one of the listed company listed in stock exchange market company, and it is a public listed GIS company. As we know, SuperMap is the only one. And these are some of the SuperMap certification, such as the CMMID V5. This is a standard in GIS industry. Sorry, this is a standard in software industry. And the OGC, which means the Open Geospatial Organization. This is a standard in GIS. And ISO is a standard about the quality. This is showing the international business of SuperMap. The orange point means there is a distributor, and the green point means there is a customer or the end user. So there are more than 100 countries have the SuperMap users all over the world. Okay, and our main topic today is the latest progress of GIS technology. We summarize them as BITDC, which is Big Data GIS, AIGIS, 3D GIS, and the distributed GIS cross-platform GIS as a basic to support these three technology. So all of them, we call it as BITDC. And I will show you them one by one. The first one is cross-platform GIS. This is very easy to be understood. At the beginning of GIS application, always it only can run on Windows. They are all based on the Windows C#. They are using the C# coding language to develop. But the cross-platform is very important because nowadays, as we know, even we cannot ban the automatic update of Windows system. So Linux brings us a lot of value. And as a GIS software, it's very important, it's very useful for it to support both of Windows and Linux. Linux can bring us a lot of benefits, such as it is free. We don't need to purchase it. And the second one is Linux is more secure. We can control every one of it. And also it has a better performance. Even there is no, in the same configuration of hardware, the performance of Linux is better than Windows. So SuperMap software supports the cross-platform, supports all of the mainstream operation system, such as Windows, of course, and SUSE, Red Hat, CentOS, and others. So that one is very simple. It is a basic of the BITDC. And the second one is distributed GIS. For talking about distributed GIS, I want to show you from these 5 topics, which also the 5 technology of distributed GIS. They are cloud native GIS, HGIS, distributed spatial analysis and processing, distributed spatial data engine, and GeoBlockchain. Every one of them is the most advanced technology in GIS industry. So the 2.1 will be distributed relationship database to support storing the spatial data. Like Oracle or SQL Server, they cannot store the spatial data directly. Only need to use or need to based on the spatial data engine to they have the rule or the capability to store the spatial data. But that one is very basic. It's very it's very traditional. For now, the distributed spatial data engine means there is a need to store the spatial data distributedly. Such as for file system, we can store them in HDFS or DSF. These two are the advanced distributed file system. We provide the capability to provide them the capability to store the spatial data. And for distributed SQL spatial database, like Oracle RAC, SQL Server Cluster, PostgreSQL, and also some other cloud environment. So for this kind of database, first they are the advanced version of their traditional one. Like Oracle RAC is the distributed version of capability to store the spatial data distributed. And for NoSQL spatial database like HBase, MongoDB, Elasticsearch, every one of them has their own advantage, such as HBase is very good to store the vector data. And MongoDB is very good at to store the tiles data, like the 3D tiles or the 2D map tiles. And Elasticsearch is good at to store the real-time data. For example, if we connect to the JS with IoT, then we can use the Elasticsearch to store the real-time data. It is very good at it. And the second one of the 2.2 is GeoBlockchain. So what is blockchain? Blockchain is very, very popular over the world these years. So the blockchain is a special data storage method with following features. It has the high security and it is traceability. It has traceability and it has a high credibility. I think we all know the Bitcoin. The Bitcoin is based on the blockchain. But how about if we integrate the blockchain technology with GIS technology? So we can imagine that the GIS data also can have these 3 features. The GIS data is also high security. No one can easily change it. No one can easily visit it. And it has the traceability, which is everyone can know the changing history of every GIS data. And it is also the high credibility or the transfer resistant. So blockchain plus GIS means it is the GeoBlockchain. The GeoBlockchain is a high reliable distributed spatial data engine. There are some demo. For example, they of the information is moving, we can track the history data for every node, and it has a high reliability. It is very the data is reliable. Then for the customer, we can believe this data. We can believe the quality of the food. So this is one of the application. And another one is for the cadastral data, we can use the geoblockchain to store them because the cadastral data has a lot of related information, and it is related to money. Yeah, and we everyone don't want my house or my land has been changed by the maybe by the agency wrongly changed or by others to change my land. So so if we store the cadastral data into the geoblockchain, then every data is reliable and every change can be traced. And also there are some other application scenario of geoblockchain, such as in the planning management. We can use it in zoning and land use control or real estate registration and transaction, and the natural resource asset and equity management. On other scenario, like other management, such as the food supervision and traceability, the logistic tracking, and city management, they all can be used of geoblockchain. Okay, and then it is the distributed spatial analysis and processing. The distributed spatial analysis and processing is for like earlier, we always, if when we want to handle a big volume of spatial data by one PC or one machine, it always take a long time because the data is big. So the distributed spatial analysis can help us to split over single complex task into a lot of child tasks. And every child task can be handled by one independent machine. After the analysis, the result can be combined together as a final result. In this way, it can help us to improve the performance to rise the speed of spatial analysis. So this is one of the advanced spatial analysis methods, such as the demo now is showing the distributed computing geoprocessing. And next is the cloud native JS. Cloud native is also like very hot these years. A lot of IT application moved from the traditional environment to the cloud native method. So what is cloud native? Or it is the microservice and containerization deployment. That is for the traditional JS environment. For traditional JS project, the minimum unit always is a server. And I mean the software server is not the hardware server, the software server. And in the server, there are a lot of services, maybe hundreds. But in this case, if some of the service has a problem, it crashed. It will the whole server will crash, or this service will affect the performance of other service. In order to avoid this situation, we can use the cloud native. The cloud native is split the whole complete server into a lot of different modules or services. And then we use the container to contain some of them. Then every container is independent, such as Docker. Every Docker is independent. It is a lightweight operation system. So every container if some of the service has problem inside of the container, it won't affect others. That brings us a very advanced method to do the operation and maintenance for our cloud server. And so it has, it can bring us the value of fine grained, high elasticity, and independent and fault isolation. So how to manage the thousands of service instances? Supermap can work with the Kubernetes to provide us the capability of load balancing, service self-healing, and elastic expansion, such as this is showing the microservice auto-scaling while visits change. We can say every square means one service instance, and every square means one service, and every green node means one service instance. This suggests these two green nodes provide the same capability of provide the same service. So if one of the service the autos, and also the recover fault is when there is one service instance has a problem, it can automatically to create a new instance to replace the fault one in order to promise the stability of the whole service. Okay, such as there are some case. For example, this is a geological big data system of Yunnan, and it includes a lot of data, and the total data volume reached to 400 TB, and there are more than 400 service instances. All of them were managed by the cloud native system. And the last one of distributed GIS is the HGIS. The HGIS, it is the distributed collaboration of edge and cloud to improve the service performance. For example, if we have a cloud center in the capital of our country, but our user is all over the world, over the country, even over the world. Sometimes when the distance between our end user and our cloud center is very far, like our user is far away from the cloud server, sometimes the network is not very good. So in this case, we can deploy one edge server near the user site. Then every time when the user wants to visit our service, they need to go to the edge server first, and the edge site, if there is already some cache or proxy on the edge, then it can return the result directly. And if the edge server cannot handle this request, then it will forward the request to the cloud center. So the edge server is based on some proxy and cache technology to enhance the performance when the network is not good. Okay, as a summary, the value of distributed GIS is high availability, high concurrency, high elasticity, high performance, large capacity, and high reliability. These are the values of distributed GIS can bring to us. Now we are going to the third subtopic inside of BITDC, which is, the first one is big data. Okay, now let's talk about big data GIS. Big data is very popular, it's very hot. Almost all of the application or all of the system want to use the big data technology. And the big data GIS is the integration of GIS and big data. I will describe to you from these three levels. The most bottom one is the spatial big data storage management. We will discuss how to store the spatial big data, and then how to do the analysis and processing for the spatial big data. And the last one is how to do the visualization for the spatial big data. So first, the storage management. Actually, the storage management is just based on the big data technology and distributed storage. This is one of the demo about the visualization of the flight over the world, and we can see from this video there are there are 2.5 billion records, and we based on we use the big data GIS technology to handle this number of data at the same time, and also we can draw a bound to achieve a query function, and we can see the the performance is pretty good. Okay, and there is another case which is the transportation information system of Chongqing, which is a big city in China. And this system integrates the different types of data, like the population, road network, traffic, railway, public transit, resident trip, and the traffic distribution, the commuting population, the recent OD and district OD. There are 3 billion new data every month. So this is also based on the big data GIS. And about the analysis and processing, there are some cases, such as this one is the COVID-19 big data system of Heilongjiang, which is one province in China, and it provides the capability of patient's history trajectory reviews and patient's activity district hotspot analysis. They are all based on the big data of such as the mobile signal and also even from the social media. And another one is the Princess Poverty Elevation System. This is a big project in China, and it aims to help the poor people live better. And this system can provide us the capability of poverty population hotspot analysis and historical change analysis. Also, the poverty population distribution and education level analysis. Each details to every person, so the data volume is pretty big. And the third one is the spatial big data visualization. For example, this is the better method than the earlier airport case. And this is based on the hotspot and overlay and show it with a timeline to show the dynamic information of flight. Because as earlier, if we show the flight points one by one, every of them should be shown on the map, it's too chaos. So if we use the heat map to do the visualization, it's much better for us to understand the data information. And another one, and this is a real-time traffic visualization of Chongqing, which is also come from the transparent system, and we use the red line moving and showing the trajectory of traffic information, and it looks much better, right? And this one is the house pricing changing map, and we can see we use the bar map to show the value of every point, and it's much clearer for us to get the information. All right, that's about the big data. And the fourth one is the AI-GIS. The AI is also a latest technology from IT, and the integration, the AI-GIS is also the integration between GIS and AI. So there are many three parts or three types of function can be provided by the AI-GIS. They are GeoAI, AI for GIS, and GIS for AI. So the GeoAI means the most integrated part between GIS and AI, and it can provide us the functions such as the geospatial machine learning, the geospatial deep learning, and the AI for GIS means how the AI technology can improve GIS. And GIS for AI is how GIS can help AI to improve its capability. There are some operators. It's too complex. I think we don't need to show them one by one. But for the types, the GeoAI can provide us the function of classify analysis, the cluster analysis, the regression analysis, spatial temporal analysis, 3D analysis, and image analysis. The image analysis is most commonly used, such as object extraction, object detection. That is based on the satellite image data, such as this one. This is object detection. And this is from one of our real projects, which is in Indonesia. As we know, Indonesia is the palm tree export country, which is the biggest one. For our customer, the palm tree will be their asset, but they have a lot of palm tree. It's hard for them to count them one by one. So based on the image data, they want to know how many trees they have, and also they want to know the status of every tree. So based on the GeoAI, we can detect the object of trees from the image data. And it is the same by others, such as we want to detect the cars, we want to detect the hole on the map. So we need to, based on the image data, to train the model using the GeoAI to train a model. And then based on the model, we can do this, we can achieve this kind of application. And the land use classification. The left side is image data, and the right side is vector data, which gets already finished the classification based on the GeoAI. And also, this is a traffic prediction based on graphic neural network. It can show us the traffic situation in 1 hour later, and the accuracy can reach to 92.7%. We can see from here, and it is very helpful for the transportation management. And the GeoAI process tool, it shows us the basic steps to use the GeoAI. First, we need to do the data preparation. That is based on the image data and the sample data. We need to get the training data generation, and then based on the training data, we need to train the model, which is model construction. And the last step is to use the model reasoning, and post process of reasoning. And in Supermap and desktop apps, we can easily achieve all of them. And this is showing the steps to extract the road from image data, such as the raster road, and we get the classification like this, and then we can generate the vector road. Okay, And the AI for GIS, as I mentioned, it is the AI helps GIS to improve its function, such as this one is the application of AI plus AR data collection. We can, the surveyor can use the mobile phone to open the camera and just pinpoint on the camera, then walk around this area. After that, the data of this area can be collected and can be uploaded to the cloud server. And also we can use this to collect the point cloud to get the indoor 3D model by scanning using the camera. And also the AI can help the GIS to raise the accuracy of indoor localization. And this one is based on the AR and AI to have the accuracy location in indoor. And also like the indoor navigation, we can use the virtual sign to show the navigation to have a better experience. And also it can be used for the smart industrial park, such as we can use our camera to scan the car and get the information and scan the light to get the information of it. Okay, and the last one is GIS for AI, which is after we some of the functions such as based on the AI camera to detect the number of car. For example, we can say there are lots of camera points, and when one of which we can get the real-time CCTV camera, and by this camera, the AI technology can detect the type of car and also detect get the transparent get the traffic index. And after get the index, we can create the heat map based on the GIS technology to show the traffic situation over the city. And also the spatial analysis for AI, that is when we, based on the camera to detect the car, we can draw a polygon. And this polygon can attach with the camera. When there is some car going through this polygon, we can get a prompt. And this way is only for the bus. So if some other car go to inside it, we need to get the number of it and the type of it. All right, now we are going to the last technology of BITDC, which is 3DGIS, and that is the T in the BITDC. The 3DGIS is most comprehensive technology in this comparing with the big data and with the AI and also like the geoblockchain. The 3DGIS technology already has a long history, and but it's growing. It never stopped developed. So this is the architecture for the 3DGIS technology. Let me show you them in details. Sorry, it seems, yeah. So the first one is the 2D and 3D integration model. The first for the, we can see from this graph, the both 2D and 3D integration model is the most basic of 3D GIS technology, and it uses the traditional 2D vector data. For example, for the 2D point, line, and region in 3D, we can have the 3D point, 3D line, 3D region, and the 3D solid. And the network, we can have the 2D network and 3D network. And for the field model, like the raster data, in 2D, we have the 2D field model as thin or grid, and in 3D, we can have the 3D field mode like team or voxel grid. For example, this is in a 3D GIS application to show the geobody, the underground lines. And this one is another one to show the profile analysis based on the geobody. We can get the profile of underground to see the detail to see the detailed information. And for the voxel grid, okay, for the voxel grid, we can use it to express the continuous 3D space information, such as this one it is based on this is using the voxel grid to show the light analysis. And if the color of every grid is more red, means this point can have more light. So we can base on it to express the continuous 3D space. And also like use the voxel grid to show the simulation of communication signal. And the second one is the 2D and 3D spatial analysis, such as this is showing us the 3D spatial analysis based on WebGL, such as the first one is the visibility analysis. That is when we draw a viewpoint and some target point, we can analyze whether we can see the target point from the viewpoint. This is the visibility analysis. And next is the skyline analysis. That is to generate a line between the sky and the model in the 2D part. And also, if we move to another camera, we can save the viewpoint and the skyline model. And this one is showing the viewshed analysis. That is, from the viewpoint, we can render the different color on the model or the ground. The green color means we can see it from the viewpoint. And the red color means we cannot see it from the viewpoint. And we can also save the result. And this one is showing the integration between the outdoor and between on the ground and underground. Okay, and next is the real-time display of 3D spatial analysis based on GPU. GPU is a graphic card. So based on the GPU, we can have a better performance of results, and also we can save it. We can save the results. And it also has a function of 3D spatial relationship judgment. And the 3D spatial computing, like we can compute, we can dig the hole in the terrain by using the Jode model. And based on, and we can also achieve the real-time viewshed analysis and 3D spatial query, such as on the left side, it is a viewshed analysis. The green color means we can see it, and the red color means we cannot see it. But on the right side is based on the viewshed analysis, we can query the information of the object, such as we can query the seats of object to simulate the camera, CCTV camera. Okay, and then it is a multi-source 3D data integration. Besides of the traditional 2D data and 3D data, there are a lot of new types of 3D data. And here I listed some of them, like Turing, oblique photographic model, the beam model, field data, pipeline, point cloud, water body, fine model, and geological body. First, let's talk about the oblique photogrammetry module. That is a very easy module to very popular one, very popular data format. And we can see, and the oblique photography module is captured by the UAV, such as we can fly a UAV around this area, and there will be multiple camera inside of the plane, like 3 or 5, and they can take the picture of one object, such as one building from different angle, and after that we can generate the 3D model based on the picture. So after we import the oblique photography module to the GIS, first we can do the object expression. We can overlay the vector data and the oblique photography data to achieve the object expression. And we can store the attributes, such as for the building, we can store the attributes of the we can store the attributes of this building, and then we can click to query the information of building based on the oblique photography model. And this is another one to show the oblique photography model in the mountain area. We can see from the far distance, the performance is pretty good. And based on the AI, we can also achieve to extract the model, the building bottom automatically. Like from the oblique photogrammetry, we can extract the building bottom, and then we can overlay it with the model, and then we can based on it to create the thematic map. The second important data source is the BIM, Building Information Modeling. So the BIM is first the BIM model is different with the traditional 3D model, and the most differences is the BIM model is very detailed to every object inside of the building. For every, such as if we have the building, if we have the BIM model for one building, then every table, every wall, every door, we can get the detailed information, detailed attributes for each. So how is the BIM model represented on GIS platform? The BIM model has its own software, such as the Revit, the Bentley, CATIA, and Autodesk Civil 3D, and also SketchUp or IFC is a format. Then in Supermap, we can use the conversion tool to convert the BIM model into GIS data. And this one is the integration between the BIM model with geologic body. We can see that this pipeline is a BIM model. We can show them together and check the attributes of every object from the BIM model. And next is the point cloud. The point cloud is very easy to get, and for example, this is showing the performance to rendering 300 TB point cloud data on the web. And the last one is the 3D model data standard. Because the 3D GIS has a short history comparing with the 2D GIS. So there need to be some standards to define the format of 3D model. And in Supermap, we released one international common use standard, which is S3M, the spatial 3D model format. Then for all of the 3D model data like BIM, vector, point cloud, turbine, image, oblique photography model. In Supermap, you by using Supermap, you can converge all of them into one unified 3D format, which is S3M. And after that, yeah, this one for the multi-source data, we can convert it to a unified data format, and then we can use the server to publish it. And after that, in the user application, we can render the 3D scene on different terminals like PC, web, mobile, VR, and AR. And this is the performance to render the S3M using Supermap iDesktop. Okay, and the last one is the last one of 3D GIS is interaction and output. First, the 3D GIS application can be run in different terminals, like in WebGL, which is on the web browser, and on mobile, and on VR device, which is we need to wear the VR glass to see the virtual reality, and the AR that is based on the mobile camera, such as this one is to show the underground pipeline by using the camera. And besides of that, the S3M also can be used in the game engine, such as Unreal Engine or Unity, the UE or Unity, such as this is the 3D virtual effect of ocean and sky, and this is showing the game engine effect on the website by using the GIS data. Also, by the UE, we can achieve the dynamically load the global 3D data to show the GIS 3D scene and show it in a better way by rendering from game engine. And also, like this one is a 3D GIS data plus gaming experience, such as there is a fire, then we can drive the car to do visage. And we can also achieve some GIS analysis by the inside of the game engine, such as this is the profile analysis, and and also the slope and aspect analysis. And this is to generate the ISO line based on the terrain. And even we can import the GIS data as the background, as a base map of gaming, such as this is a virtual battlefield simulation, and the data, the terrain is from the oblique photogrammetry data. So this is the oblique photogrammetry plus game spatial effect. Okay, let's review the 3D GIS technology. From the bottom, which is the basic, it is a 2D and 3D data model. And then the multi-source 3D data integration is very important. And besides it, we have the spatial 3D model data format, which is S3M. And on the output side or on the terminal side, we have different terminal to show the 3D application. Okay, as a summary, the Supermap GIS technology system, we call it as BITDC, which is Big Data GIS, AI GIS, 3D GIS, Distributed GIS, and Cross-Platform GIS. And this is the Supermap GIS 10i product system. We have in the center, in the cloud side, we have the Supermap iServer for publish the services, publish the spatial data and GIS capability to web. And iPortal is for to create a unified access for the cloud center. And iManager is focused on the operation and maintenance. On the edge side, we have the Supermap iEdge, which can help us to enhance the performance when the network is not good. And on the terminal side, we have the terminal GIS for desktop, iDesktop X and iDesktop, and terminologies for components, terminologies for web, and terminologies for mobile. For the further course, we will mainly use the SuperMap iDesktop. All right, this is about the introduction of latest progress of GIS, and the last part of today's course will be about the homework. So today's homework for you is to download and install the SuperMap iDesktop. This is the interface of SuperMap iDesktop, and first we need to download the iDesktop from the SuperMap website, which is supermap.com. You can just input the supermap.com, or you can download it from the document directly. And from this one, you need to choose the SuperMap iDesktop and Win64 or the Win64bin. The bin means it has a smaller package and without the sample code and sample data on it. Actually, you can download this one if the network is not good. Yeah, these two, the SuperMap iDesktop, Win64 or Win64bin. And for the installation, after you download it, first you need to unzip the package and then right-click on the setup.exe and use the administrator to run it. This one, right-click at the setup.exe and run as administrator. Then you just need to click next, and choose the folder, then click next, and choose the complete, and next, then it will be finished. And for the license configuration, if it's the first time for you to use SuperMap iDesktop, you already install the license automatically when you install the SuperMap iDesktop. But if you want to install the license center independently, you can go to the license center and run as administrator to check the license. So after the installation, when you run the iDesktop, you can see the interface like this. All right. Thank you for your listening, and for the homework submission, please provide the screenshot and upload your submission to the Google Classroom. Thank you, everyone. That is all for our training today. Thank you for your time.